it is my very honor to introduce Tuana Çelik. I hope I'm not butchering her name. And Tuana, folks, specializes in AI engineering with a focus on language technologies. And in this video, she's going to demonstrate how memory blocks and retrieval pipelines create controlled, relevant context for complex tasks. Now, folks, when I say that she focuses on language, I mean language technologies like large language models, using Python. She works at LlamaIndex, which, needs no introduction. And she brings prior experience from roles at Weaviate. Folks, if you don't know about Weaviate, if you don't know about vector databases, go check out Weaviate. They have some really unbelievably good resources. All right. She's a passionate builder and a passionate educator. And folks, from this video, you'll see she's an extremely effective and talented educator as well. She creates tooling and educational resources for tech communities and frequently shares her expertise by giving talks like this one on AI and development. So folks, let's hear from Tuana, her perspective.
Hi, this is Tuana from LlamaIndex, and I'm going to be talking about context engineering, but specifically I'll be talking about the role of memory when it comes to context engineering. When we talk about context or context engineering, we're really talking about a multitude of things that work together to form the most relevant, accurate, or effective context for an LLM or an agent to work with to give us the most valuable, reasonable answers. This could be the prompt, it could be tools, it could be memory, it could be a number of things. And in this particular presentation, I'm going to be talking specifically about memory. But even when it comes to memory, we have quite a few types of memory that we could be talking about. And over the last few months at LlamaIndex, we've been introducing different types of both long and short-term memory blocks. We are going to be discussing a particular memory block that we call artifact memory block, but you could also use memory blocks that we call static memory block that simply hold static, basically unchanging information or information that changes very rarely. You could use fact extraction memory block, and this is probably useful for applications where we really need to rely on the latest facts to be able to give the most relevant answers to users. We also have vector memory block, which is a great way to extract past conversation or chat messages that are most relevant to today's conversation. And finally, we have artifact memory block. This is kind of similar to the fact extraction memory block. However, it allows us to incorporate a short-term memory component that keeps track of some sort of structured information. So for this example, we're going to be imagining that we are a restaurant or a pizzeria, and we are providing a order tracking bot to our customers, and they can have conversations with this bot, but our main goal, our main aim is to get to the final order that they want to place. So you may imagine, although most of the conversation might still be relevant, it's probably not that important to guard the entire chat history as context and really boil down to a few key bits of information. For example, the pizza, the things they want to add or remove to the pizza, the address, and so on. So without further ado, let's start building an agent that makes use of the artifact memory block. And also we will define what percentage of the chat history we keep and what percentage is remaining for the system prompt and our artifact memory block. I've already defined the imports. I've already installed everything that's needed here. And I've also provided my OpenAI API key. I will be using an OpenAI model here, but you can use any other model of your choice. It does not have to be OpenAI. And now with all of those prepared, we can start by defining our artifact that we want to use as our short-term memory block. We'll start off by defining a pizza class, a address class, and then finally the resulting artifact that we're going to want to use is going to be called an order that can consist of multiple pizzas, but a single address. For every class we define, we also provide descriptions for every field. This is additional context that's going to be super relevant to the large language model. While it's looking through the conversation, it's going to be able to use those descriptions to decide what in the conversation relates to this field. For example, what in the conversation might be something it could assign to the pizza name. Next, we also define an address. And finally, we define the final artifact that we want to keep track of, which is going to be the order class. Okay, now that we have that, we can start by defining our artifact editor tool, which is going to be a tool that our agent uses to edit the artifact along the way. And then we can define our memory block. First, we convert our tool spec into a list of tools that we'll be providing to our agent. And finally, we define a memory block. Here you can see that my memory block is using the artifact memory block with the tool spec that I provided above. I'm also here able to define exactly what ratio of the context consists of chat history versus what remaining ratio is dedicated to my artifact memory, and also maybe the system prompt and anything additional that might be coming our way. In this case, we're going with 70%. So 70% of the entire context is still chat history, but everything beyond that is going to be dedicated to my system prompt, which is going to be relevant for the large language model to understand exactly what its purpose and role is. And then it'll also be my artifact memory block that is going to be taking up the remainder of the 30% of the context. Now that we have that, we can start by defining an LLM. I'm going to be using the GPT-5 model by OpenAI. And then we can define our order tracking agent. In this case, I'm going to be using a special agent class that we call the agent workflow in LlamaIndex. This agent workflow is able to deal with multiple function agents or multiple agents, if you will. In this case, because we want to have a tool that can edit our memory block, I've gone for using a function agent with this particular system prompt. You are a worker at a pizzeria. Your job is to talk to users and gather order information. I've also added some extra instructions here. At every step, you should check the order completeness before responding to the user and so on. Now I have this agent workflow. I can create a very simple chat loop. And in this particular case, it's super simple. We have a loop that will exit if the user types exit or quit. And unless they've done that, we are running the agent with our memory block that we defined earlier up here. And this will be keeping track of our artifact as well as the rest of the chat history. With that, we can now start chatting with our order tracking agent. Let's start by saying I would like a pepperoni. All right, as you can see, it's decided that the current state of the artifact is that we have one pepperoni. I've not removed or added anything, and I still don't have an address. And you can see that the agent is actually acting in a relevant way. Is this for pickup or delivery, etc.? So let's complete this order. I've completely made up an address here, and I've also asked to add olives. Hopefully it will also be able to work with my typo. All right, we've now exited the conversation with the agent because we never defined exactly when this whole order placing would be finished. We only described an exit or quit statement as a way to leave this conversation. And you can see that it's been able to keep track of exactly what it's after, which is the name of the pizza, any additions, and the address. And we made it so that instead of having the entire chat history as a way for the agent to sift through and understand exactly what order should be placed, we were able to provide an artifact memory block and keep track of a specific artifact that we were able to define. Once we've completed this, we can also have a look at the final artifact, which seems to be correct. One final thing I want to mention about context engineering and LlamaIndex are agent workflows, which really is a way for you to construct context along the way. A workflow is basically a way that you can define every single step that your agent is taking, whether that's a decision step or an outcome step or anything in between. It allows you to really have full control over all of the steps that your agent is taking. It's actually super simple. It's a class that you can extend, and you're able to define your own steps and events. And the step can trigger an event, but it can also subscribe to an event. And you can also then visualize exactly what your agent workflow or orchestration is going to look like. Here on the screen, you're already seeing a workflow that does nothing, but that is completely legit. And you can visualize it as a single path workflow. But you can also have workflows that branch out, that loop, and every step you can imagine is providing something extra to the context, or maybe optimizing the context. And with that, here is the article me and my colleague Logan wrote about context engineering, where you can go and explore all of the different types of memory blocks that we didn't have a look at today.